He's recycling my recycling. Okay. What do I need to do? Okay. I need a new phone. What I really want is the functionality of the 8S and the form factor of the 8, which the closest you can get is the 10. And gah. So I can hear you, but
Yeah.
I'm on different systems.
Yeah.
Can they hear me?
Now can they hear me? Yeah. That's weird that it did that. It seems to be doing that every time, but maybe it's because I unplugged my audio and then plugged it back in again. Okay. Yeah, they should hear me now. Well, then you'll never know what I said. You'll never know the dark secrets of the universe that I revealed. Sorry. So in the end, are you going to be buying that phone? Carla's has owned every single iPhone right from the beginning. So
I normally get like every whole digit even phone. So I had like 2, 4, 6. I'm stuck on 6 currently. My 6 is like on life support. It has an external battery because its own battery had failed, and this case was cheaper than replacing the battery. Admittedly, I also stole the case from a really good friend. And so like I have to get a phone, and I don't know what to do. And so I'm going to stare at my AT&T plan and contemplate.
So folks, YouTube is telling me that my video resolution is 720, but I'm sort of pushing out a 1920, a 1080p stream. So I'm gonna have to stop streaming for 1 second, switch over the setting, and I think this will be okay. So we're gonna go down for 1 second, and then we should come right back. So hang tough. Apologies. You will not be able to restart. What? Okay, then never mind. It says it's not optimal, but you know what? We're just going to go with it then. Never mind. If I can't stop it and restart it, then I don't want to do that. Why would they? Anyway. Yeah, so thanks everyone for joining us at this wacky time. There's not a lot of you, but we know that this is what is necessary before I'm going to be gone for a couple of days. So I won't be here on Friday. But I think this is it. Actually, I've got a conference to attend in November. I don't know what you have.
I have my normal hellscape of fall travel, but I think that Susie and I have mostly figured out how to make everything go.
Did you fine-tune your lighting? Because it looks a lot better.
Yes, I did.
Good work.
I love my Philips Hue light bulb.
Oh, no money from Philips. Oh man. Oh great. So now there's a fight about Apple and Android in the comments.
No religious wars, people.
Yeah. I got the Pixel. I've got the Android. Pamela's the Apple.
Yeah.
So
I'm using OS X. He's using Linux or Windows right now.
I'm using Windows right now, yeah.
And we both have our servers running on Linux. We're interdenominational.
There you go. All right, let's so for everyone who's wondering what's happening with the Weekly Space Hangout, we've got there's no fight, we're all against it. There's a new we've set up a new Weekly Space Hangout YouTube channel, which I will be making a post shortly here on my regular channel that says where that is. and we posted about it in the WSH crew Slack. So at some point we will post where that new thing is, but I'll put a big ad on my main channel so you can find out where it is. But it's going to be tomorrow at 5 p.m. Pacific time, and I've already recorded the interview, so that's different and fun. I'm going to say hi to a few people. Hello to Arnold Post and Catalin Bontia and Coalfire and Daniel McCool and David B. and Ed Thompson and Elad Avron and Eric Mackey, Harry M., Holly Mayer, Jessica Feltz, John Seffel, Johnny Zed, Matt Randall, Michael Murphy, Mokopa, Paul Taylor, Psychocat 749, Rachel Fry, Renan Brazil, Rick Schwartz, Sergio Botero, Steve Heistand, Yamagashi San, Yov Landsman, and Zach Cody. Hey, everybody. Is it getting choppy? I apologize if it is. Like I said, it should be able to handle the stream, but we'll see what happens. Okay. And in the end of the day, what really matters is we will have recorded good premium audio. So
yes.
Okay. Anything you can think of before we begin?
We need to remember to mention Patreon. And since this isn't a post-actual death of Cassini, do you want to plan on making this 2 parts and review the science next episode?
Sure.
Okay.
Yeah. Do you have a timeline? Do you have a timeline in front of you? Do you need one?
I will in a moment.
Okay. I wrote
You're welcome
one.
to always share a link with me.
Yeah, I wrote one. So let me just.
Then share.
Okay.
This is where the sausage is made, everyone.
Hold on. This is the script for the video that we're making with David Joseph Wesley to celebrate the final. So it's going to be just instrumental. So it's David's music with a bunch of videos that we've put together, and then I've written some fancy words. So I don't know if I can share this at you. Okay. Okay, I just shared a link at you. So
thank you.
See if you can get that. Doesn't the podcast go out when Cassini is already gone? Yes, this podcast is going to go out after Cassini is dead, and then we will be doing one more. Okay, great.
Sorry, working on opening it. Everything is beeping at me on my screen. Beep, beep, all the things. There we go. Okay.
Okay.
I'm ready to press record whenever you're ready to press record.
I am also ready to rest record.
I am pressing report.
Okay, cool. So yeah, there you go. That's got lots of good info in there. All right, let it begin. I have pressed record as well.
Yay, we're recording. Hey, Chad.
Hello, Chad. Here we go. Astronomy Cast, episode 457, Cassini in Memoriam. Welcome to Astronomy Cast, a weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today. With me is Dr. Pamela Gay, the Director of Technology and Citizen Science at the Astronomical Society of the Pacific, and the Director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Doing great, even though this is going to be a super sad episode. There won't be a dry eye in the place. Wah, wah. Let's talk about the Patreon for Astronomy Cast now that we're here for an all-new season.
So as we go into our 11th year, for the past 10 years, Fraser and I have pretty much done this out of the goodness of our hearts, by which we mean we weren't bringing in enough money to pay anyone other than Susie and Chad, and before Chad, Preston, and before Susie, well, there were a lot of people. Anyways, we've always been a really small crew, and we've done this on a shoestring, and we'd like to upgrade the whole shebang. And more to the point, I'd like our quality to be a little bit closer to the quality of Fraser's weekly guide to space. We know what quality looks like. We know we can do this, but in order to do it, we need to pay ourselves. So can you guys help? Can you please go to patreon.com/astronomycast and give a little. If even 10% of you give $10, we're done begging. We're set. I know that's not going to happen, but yeah, can at least 10% of you give $1? Maybe?
Yeah. I mean, I think we've demonstrated that we've been here for a while, and we'll continue to do this job, and it would be wonderful with your ongoing support. So just go to patreon.com/astronomycast to support us. Even $1 a month is huge and makes a big difference in us being able to pay the team, the server, the other fundraising things that we do, as well as theoretically us. So, all right, onto the show. It's time to say goodbye to an old friend, NASA's Cassini spacecraft, which has been orbiting within the Saturnian system since 2004. But why does a seemingly healthy spacecraft and mission need to come to an end? Today, we look back at the mission, some of the amazing discoveries, and why its finale was necessary. All right, Pamela, so when we're recording this right now, we're actually a couple of days away from the finale. We're actually recording the show on the 12th. When's the finale?
It's Friday. It's September 15th, just a month shy of poor Cassini's launch anniversary.
Launch anniversary?
It launched on October 17th, 1997. So Cassini almost lived long enough to drink, but not quite.
But that's still amazing, right? 1997, that was, well, in Canada, it would be fine. But I started doing Universe Today in 1999. So when I started reporting, I was already reporting the mission that Cassini had already left, had already been launched. And I think, if I remember, like the first thing that we were talking about was the flyby that it was going to do of Earth. So it actually made a couple of flybys of some other planets before making its way out to Saturn.
Right. So in 1998, it did a flyby of Venus. And then again in 1999, it did a second flyby of Venus. This is where we use gravity to increase the velocity of the spacecraft without having to use as much fuel, which is good because it needed all that fuel now that it's out at Saturn. Then it did in 1999 an Earth-Moon flyby. It went through the asteroids. Just a little bit shy of 2001, at the end of 2000, it went and explored Jupiter, did some camera testing in 2002, and then 2004 was when the gorgeous things started to happen.
And again, I remember, now I remember sort of reporting on this stuff item by item, and we got a chance not only to see these sort of better and better images of Saturn as Cassini was getting closer and closer, but I remember the first moon, and I think it was Hyperion, was like this first, like, it looked like a sponge that it went past and began starting to do these observations of the moons and Saturn.
And for me, this was actually the beginning of my podcasting days, because it was back in February of 2005 that we launched Slacker Astronomy. And Cassini and all of the things that it went through was the early days of us talking about the voices in our heads and all they had to say about science.
Right.
So it's weird that, like, we grew up as children with Voyager, but then as science communicators, we really grew up with Cassini.
Yeah, I would say Cassini has been, I think you hit the nail right on the head, right? Cassini has been our constant companion throughout both of our science communication careers for the length of time that both of us have been doing this, Cassini has been this mainstay. And I've mentioned this previous times of the podcast where I would get emails from Dr. Carolyn Porco when I had made some mistake or failed to provide the credit or just, needed a little more information, and she was right there to clean things up, fix it, make sure I understood the right way to describe the images and the science that we were seeing. But
and I was lucky that I didn't experience any of that, because I think it would have completely mortified me, because she's like one of the senior women scientists that the rest of us are like, wow, she went through a lot. Let's live up to that if we can. But on my side, this was our chance to figure out how to tell the story. It was our chance to have a story that included so much diverse science, so much hardware, software, men, women who'd been working on this their entire lives, a spacecraft that had an amazing legacy. So this was one of those rare instances where you have the narrative, the heritage, the science, and all the pretty shiny pictures all bound up in one little mission.
And I think as well, one of the other parts that was really groundbreaking with Cassini was that it had this second mini mission sort of connected to it, which was the Huygens probe developed by the European Space Agency. So you had this collaboration between NASA and the Europeans to create this dual mission with this amazing little buddy.
Yeah, and this really sort of pointed the way to Rosetta and Philae, where you have the main spacecraft and then the little parasitic guy that flies along like a lamprey that jumps off when things get interesting. And Huygens totally worked and totally brought us science that I think some people had anticipated that Titan would be amazing. We knew that it was weird from the Voyager missions that suddenly discovered, oh, this little moon, we can't see through its atmosphere. This is sad and disappointing. Let's send something back to go through the atmosphere. And little Huygens did that. And on this world that's at the triple point of methane, where you have methane can snow, can flow, can be as a gaseous form, on this world you have a geology that's shaped by methane with river deltas and lakes and all this amazing icy geology that, because of its lower gravity, is like miniature Earth but stinkier.
Right. And the fact that what was down there beneath these clouds was essentially completely unknown. They could only see from Earth with the powerful telescopes that there was some kind of hydrocarbon in the atmosphere, and it was incredibly intriguing. When they sent the Voyagers, Voyager 1 made a close flyby but couldn't see through this hydrocarbon. So one of Cassini's main purposes was be able to both land on the surface thanks to Huygens, but also be able to peer through this thick cloud and be able to see the surface. And what it found, I think nobody expected, and it was, as you said, one of the sort of most amazing discoveries in the whole solar system.
And this is essentially a world that doesn't appear to be in complete chemical equilibrium using chemistry as we know it. So we either have to redefine geology, redefine chemistry, or find life. Pick one, at least one. It could be all three. And as we look, we see these lakes that are even more than just straight out methane. There's a variety of different hydrocarbons. They're perfectly mirror smooth, and with the variety of instruments that Cassini took with it, this is a hefty spacecraft. It is able to see in multiple wavelengths. It's able to take samples. It has radar. Combining all of its capabilities, it was able to show us that other worlds have Great Lakes and other worlds have rain and weather and storms that are not just dust, but are also wet. It's just not water.
Yeah. Who knew that the best way to explore Titan would be with a submarine.
Yes.
That's what we need in the future, is some kind of submarine, a boat, a sailboat to better explore the oceans and seas on Titan.
And how lucky did we get with Huygens that when it landed, it didn't land in one of these lakes, that instead it basically landed somewhere that kind of went crunch.
It could have. It was built. It was able to float.
It was, but I think the fact that it landed somewhere where the soil just sort of went crunch, like stepping out onto ice-covered snow, is somehow even more satisfying.
Yeah, absolutely. But that was just one of the moons. It saw Iapetus with its amazing ridge. It saw Rhea and Dione. But I think the most interesting one is what it found at Enceladus. And of course,
see, I'm still going to go with Pan the ravioli.
Sure, the UFO. I think it looks like a little UFO, but I understand that it also looks like a ravioli. Maybe raviolis look like UFOs. But Enceladus,
yes,
for pure scientific value, again, one of the most amazing discoveries in the entire solar system.
And this is, again, a world that we expected to be kind of boring. It was shiny. We knew that. We figured it was icy because shiny usually leads to icy. And when we first got pictures of it, sure, it's fairly cratered. It's not hugely cratered, but it's definitely up there when compared to like Europa. But when you start looking, you start noticing this is a little moon that has a geyser issue. Specifically, it has these dark cracks, these dark stripes, and we, on a fairly regular basis, see geysers of material coming out of these stripes that Cassini was actually able to fly through and sample, and these are ice geysers. How awesome is that?
Yeah, absolutely. And now, sort of, further on observations have shown that coming out of these geysers are hydrogen that could be the ingredients, the food for life deep down below the ice on Enceladus. Perhaps the same situation exists on Europa, a whole different planet, but still, suddenly these
Europa's
places.
A moon, not a planet.
I meant
moon or world.
I meant
pick
around.
one.
I meant around Jupiter. So
Okay,
Europa
okay.
is orbiting Jupiter, not Saturn. But that both of these places are now sort of premium places to search for life, and will be the what Cassini showed us was that these are some of the most interesting places in the entire solar system, and that this is where we need to bring far more energy and technology and exploration to in the future. But it wasn't just. Oh, go ahead.
I was just going to say, and it wasn't just the moons of Saturn. It's also the rings and the dynamics of them that we're still just beginning to understand as Cassini, in its final days and its final dives, gets up close and personal with the wave structure of the rings.
I mean, one of the because it was there at Saturn for so long, it got a chance to go through a huge chunk of Saturn's seasons. So it got to see the planet move through these seasons and see how the changes in temperature affected the storm patterns on Saturn. It got to see that enormous polar vortex, this hexagon-shaped storm that is sort of in around Saturn's pole, North Pole for sure, and see that with just amazing clarity.
And what's amazing is, as you said, we got to see it go from solstice with the sun at its extreme point on one pole through equinox, heading back through the other set of phases. And so we've now got to see this seasonal cycle, both in terms of how storms will stripe around the entire Saturnian world, these big white, starting as a hurricane and then evolving essentially into a band storms. And we've seen in parallel storms on Titan, showing us that you can get weather in multiple places. And this is all new and exciting for us to get to figure out.
And you mentioned the rings, and I think one of the most amazing part of the rings is that they got to the bottom of how several of the rings are formed, and also actually could see some of the fine details in the rings, like these wonderful little moons that move through and put out gravity waves into the rings. How there are like these moonlets can create these crazy wall structures in the rings. Things, again, that nobody ever expected to see.
And as we're looking at this, there was a fabulous cartoon that came out today. Again, today being September 12th, episode going out on, I believe, the 18th. Miles Traer, and we'll work on getting this up in our show notes, put out a cartoon on his Twitter GeoMiles account where poor little Cassini is orbiting and orbiting and orbiting and is like, woo, hexagon, cool, I'll collect more data. And everyone's like, that makes no sense. And Cassini's like, oh, I'm sorry, I'll try harder. And then trying to measure the Saturn day, still can't figure it out. That still makes no sense. And Cassini is getting more and more frustrated as Cassini fails in his little robotic heart to be able to provide Earth with data that helps explain all of these mysteries of these mirror-smooth lakes, of all these ice plumes on Enceladus, of the age of Saturn's rings. We still don't know. There's still, like, every other week it seems like a press release on Saturn's ring age.
They're young. They're old.
And the magnetosphere, all of this. It's one of these cases of we sent the spacecraft, we were going to get all the answers. And what we really got was we tripled the number of questions. And that's really what science is about. It's about having questions, trying to answer them, and constantly evolving the parameter space we don't know, while hopefully like making little tiny inroads, a little tiny step at a time as we work to understand more and more and more. So yes, we saw the waves from the gravitational dynamics of the moons creating these gorgeous structures in the rings. We have seen weird pile-ups of organics on one side and crystal white ice on the other side of moons. We've seen so many different things that we've begun to start to have models to start to understand. But mostly we just have questions.
Right. Which is, as you said, that is the job of these scientific missions. They answer the previous set, or try to answer the previous set, and then uncover a whole new set of questions. And Cassini would be no different from that. Earlier this year was when the mission, it was extended several times, but really earlier this year was when the mission started to begin its finale, and there was going to be 25 close passes through the rings, leading to what's going to be happening on Friday. So let's talk about why Cassini has to die. Why does Cassini have to die?
Well, I mean, at the end of the day, when we launched Cassini, back when I was still working on my master's degree and didn't have any time for this stuff called planets, back in 1997 and in the years and years before that, when this mission was getting planned, argued for, constructed, all of that, the idea that there could be life out in the Saturn system wasn't an idea we had. And so it isn't a sterile spacecraft. In fact, it was deemed a Category 2 moon for Titan. That means you can just go there, unsterilize your spacecraft, hop on down, explore, we're all good. But our ideas of what is and isn't habitable have evolved in the past 20 years. And as our understanding has evolved, we've realized, well, expletive, if we accidentally crash Cassini into Enceladus, into Titan, into these worlds that just might be able to support extreme forms of life, we could kill everything before we learn about it by sending our own germs and bugs that just might be lethal. So as the mission begins to run out of fuel to do maneuvers, we need to use some of what's left of that fuel to essentially sterilize the Saturn system as best we can by killing our own germs in the atmosphere of Saturn.
Yeah, and this is not the first time this has happened. This was done with Galileo as well, again, to reduce the risk that it was going to crash into Europa. It will be the future for Juno.
This is what we do to the spacecraft we love. We kill them.
We kill them. Right, but and so you're going to get this. I mean, if you just left it, before you could control it, before you could do this controlled finale, the spacecraft would just be going around and around within the system, and the chances of it eventually crashing into one of those moons is just too high, too much of a risk to take, and so they have to crash it.
In general, this has been a fairly risky mission if you think about it. We have a ring world, which means it's ringed with dust and debris that can hit and destroy your spaceship. It is a world with a very complex gravitational field. We just used the mass of Titan to... The language they're using, which I really don't like, is to kiss Cassini.
Shove it into Saturn.
Yeah, the idea that Titan's gravity was the kiss of death to Titan,
a kiss goodbye. Yeah,
that's there. A lot of the imagery associated with the reporting right now between saying that Cassini is committing suicide, that is bad imagery. Don't use that, people.
Yeah. It's being murdered.
Yes. Yes, this is willful murder by mission control. Cassini is not...
It's being sacrificed? That's the way to say
it. It is dying that other life forms that may or may not exist can live.
Yeah. So over the next couple of days, how are things going to play out? I think I got an email from Dr. Porco just a day ago that they just finished the 22nd. You said they did this final flyby of Titan to get that final slingshot maneuver to be on its death trajectory. How are things going to play out now?
So at this point, they're sending back data. This is something I know a bunch of us are really looking forward to, because that was one of the closest, I think it was actually the closest that we've gotten to Titan. And at about 5 a.m. Pacific, 8 a.m. Eastern on Friday is when we should get the final signal. Now, the final signal doesn't mean the spacecraft is dead. It means the spacecraft has stopped transmitting. The spacecraft will begin to enter the atmosphere at probably about 3:45 a.m. Pacific, and it takes time for the signal to get to us. So there's this disconnect between, it's the light of, if we were able to watch it die, won't have reached us yet when we get the final signal, but it will have already entered the atmosphere, but the light won't have gotten. It's relativity. Right.
You have to wait for the time for the spacecraft signals to reach us, thanks to the slow speed of light.
And so here we are. The northern summer solstice has begun. It saw the beginning of that new spring on the world, and now it's gotten its up close and personal views of the rings. It has performed science like a champ, sending us back gigabyte upon gigabyte of data. And now the final orbit is underway. And what's kind of amazing is it began this final grand finale of 22 orbits a long time ago, because it's not a fast process. It's a big world. These orbits have been dragging it out past the outer rings. And so it takes time, and we've all been sadly watching these last 22 orbits go by.
Right. Now, a couple of questions that I'm sure people are going to have is how long will it take? Like, how deep will it get into Saturn before it's destroyed? Will it reach the surface?
Well, no. It will be crushed like a styrofoam cup going into the ocean. We don't know exactly when it's going to die. There's just certain things that we can't know.
It won't get far.
It won't get far.
No. And do you remember when Galileo was crashing Jupiter, people were freaked out that it was going to turn Jupiter into a second sun?
Yes.
Yes. I guarantee they're thinking about that this time. So what would it take to turn Saturn into a second sun?
Several Jupiters. By that, I mean like 20 of them.
More.
Well, if you wanted to only burn briefly with tritium,
right?
You don't need quite as many.
Sure.
But yeah, it's not going to happen. We're good. So here's what we're looking at that will have already transpired by the time we hear this. Those of you listening to this as a podcast, well, it was Tuesday night, the night that after we were done recording this, that the downlink of that final Titan data began. Then on Thursday, there was the final images to be taken late afternoon here in the United States. And the spacecraft turned its antennas towards us and spent that evening sending us back a playback of the data recorder. And for 14 and a half hours, it just continuously said, here's my data. Go understand my world. It ended its communications with science. The signal got passed from station to station, where it was actually the Australian station that got to say goodbye. And yeah.
At this point, you will hopefully have seen the final picture, which has not been sent yet, but it's going to be that closest possible photo of the surface of Saturn, or the cloud tops of Saturn. Although, I mean, the close pictures that have already come back are just amazing how much closer it is than it had ever been. But we will get that final picture as it's roaring in to wrap up the mission.
It's really those ring crossing pictures that get me. Just seeing all the fine structure in the rings. And like I said, they still on a regular basis are like, they're new, they're old, they're new. We still have so much more to learn.
You are literally tearing up.
I'm trying not to.
All right. Well, I think we may have another conversation next week. So I hope we get that final picture. I hope that final picture is amazing. I know the science was worth it. Thank you, Pamela, and we'll talk to you next week.
Sounds great, Fraser. Talk to you later. And we save. Saving.
This is
Welcome to the boring part. 56.
No, 457.
57. Okay.
Yeah.
And we're going to do micro questions today, by which I mean let's take like 2 because sure. I have to go run somewhere before 4 o'clock.
Gordon asks, is Cassini expected to impact on the Earth-facing side of Saturn or the other side?
I believe the Earth-facing side. I could be wrong.
Right, but you would think that they would have timed it to make sure that we get as much of the data, because otherwise we wouldn't see it.
Yeah.
But we absolutely can't guarantee that that's the correct answer. But that feels like that would be the thing that they would try to do.
Yeah. Okay, one more question, and then I have to go run an errand. I'm so sorry. I will make it up by twitching my calculations of Pluto later today.
John Suffolk, would Hubble be able to see it burning up in the atmosphere?
I don't know about Hubble. I know that there are going to be telescopes on the ground pointed at Saturn, observing what's going on.
I don't think they saw Galileo when it went, and that was closer, and that was you know, a better shot to see it. So it's just too far, and it's just too small.
Yeah.
So, all right, that's it. That was those were your 2 questions.
Okay.
Thanks everybody for joining us this week. Apologies. Remember, we've got the new season of the Weekly Space Hangout starting tomorrow night at 5:00 on the Weekly Space Hangout channel, which, again, hopefully someone could just put that in the chat right now, but I will be posting a video within a couple of hours promoting that show for tomorrow. So it'll be on my YouTube channel. So hopefully you'll get it. All right.
And Patreon, if you love us.
Patreon.com/astronomycast.
Patreon.com/astronomycast. Because we love you.
All right. And Cassini. Thanks, everybody.
Yes.
We'll see you all next week.
Bye-bye.